All right, recording started. So, all right, let me actually present the second screen then. So I can see what's going on. All right, you guys want to summarize what's going on here?
Right, sure. So there was a proposal on laying down the framework for enabling hardware intrinsics, right, from Russ here. And what we have done at Intel is to use that as a groundwork to propose a set of hardware intrinsics for C#, right? So if you're already familiar with hardware intrinsics in C, C++, it basically allows you to take full advantage of the underlying hardware by being able to emit the instructions for that underlying processor. So, vector T in C# sort of allows you to do that, take advantage of SIMD capability of the processor, but there have been a lot of questions asked on GitHub, from developers asking for, they want to have full control, explicit control of how their program is code-gen and executed, right? So this proposal basically addresses that concern or capability ask. So we are proposing a new namespace, system runtime compiler services Intrinsics, for exposing types that would correspond to the underlying hardware registers. So in this case, we are proposing vector 128, which would correspond to XMM registers on Intel architecture, vector 256 for YMM registers, right? And we are saying that those types doesn't have to be hardware specific or vendor specific, because if you have ARM, they can have one of these vectors representing Q register, for example, right? And then we are also proposing intrinsic.x86 namespace, where instruction or intrinsics that correspond to x86, x64. So the name is kind of loaded, right? x86 can mean Intel architecture, but also can mean 32-bit or 64-bit. In this case, we are using x86 as IA, which would include Intel and AMD. We preferably would like to name it Intel, but I don't think not everybody is gonna agree with that. So that's why we chose x86. And then within the namespace, we're proposing different classes that represent different instruction sets. So in this example, we have AVX, but we are also proposing class for AVX2, SSC2, and so forth. One of the things that we are proposing is to use SSE as the lowest ISA. Some people had questioned about whether we should separate SSE and SSE2. So that's something that we may need to discuss. In the current form, we are proposing SSE2 as the base ISA.
So I have a question about the first sentence on this page. It says that it's a C# feature. I assume that's a general.NET CLR feature, not a C# feature, correct?
Yeah.
Yeah, that's what I was wondering too. And then,
Too small to break?
Well, no, it's just compiler services. Compiler services, we usually use that namespace to hide stuff we don't want people using. Like async method builder and things that are very specific to compiler implementations. But I don't know if it would be runtime services, or I don't know if we have anywhere where we put runtime specific items. But that's not a big issue.
There was actually somebody. So this we put this out maybe a couple of weeks ago, or less than a couple of weeks ago. It drew quite a few comments, and I think one of the comments, or a few of the comments, was actually referring to the namespace name. And I don't know what the suggestion was.
Yeah, somebody I remember mentioned that as maybe intrinsic is not a good name for this namespace, because on the core already has some other intrinsics, and he suggests maybe we could use hardware intrinsic here. Yeah, something like that.
So instead of just using the name intrinsic, say hardware intrinsic.
Yeah.
So I know that a long time ago, or at some point, compiler services was supposed to be the namespace that like nobody ever uses. It's a good that the compiler generates. Is that still true in practice today?
We're looking up something.
It's most of the time people should be using code.
Didn't we put unsafe in there too? The unsafe assembly system runtime compiler services unsafe. Is that what we call that?
But even if it's not perfect, if it's close, if you guys feel it's close enough, I would.
But it's more
keep
like
compiler services as a namespace that people don't want to import, don't need to import. We could put it system runtime intrinsics. Keep the compiler services.
Yeah, compiler services has a lot of stuff like extension attribute, like isConst, which is used by C++ team. It's typically used for types that the compiler at emit time, where we're like, oh, we need to put an attribute here. We need to implement. There are certain interfaces that we use to share things. You have like async method builder is in there. So it's a lot of these kind of like primitive types that we use just during code generation.
Right.
So it's usually we tell people never, if you import that namespace in general, it's the wrong thing to do.
I would just remove
If they
compiler
do, they'll
services.
see all that crap, right? And usually get confused.
Yeah, and then they might start using it, which is always fun.
There are
Yes.
some things I'll use correctly with it.
Yeah, and those are mostly considered mistakes. But like the dynamic attribute is there. Like
Realize that there's to me, CPU would make sense, or processor intrinsics, or
Those things,
something.
processor.
Because these APIs are very different than the rest of the framework.
So you still want
You kind of want folks to knowingly enter into this world.
But I don't think that. So definitely, I would not put it in system runtime directly.
No,
But
right.
if it's system runtime intrinsics, I don't think even with any name we would explain that those are special ones. So system runtime intrinsics, we could basically say this is the namespace. It has special rules. You need to know what's happening here. And
To me, intrinsics already communicates that there is it says literally runtime intrinsics, right? Like it implies there's some handshake between the author of the code and the runtime behavior, right? And like it's not just
so long as
Such a collection.
we wouldn't want to use that name for something else that doesn't.
doesn't fall in the same category.
yeah, I would say basically if we decide system runtime intrinsics, it would mean it's a namespace with APIs that you don't know whether they are not portable, basically, right?
well, especially with I guess the idea here is that we would put stuff into intrinsics that we expect to share at least among different processors, right? So I guess a vector 128 is a vector 128, no matter whether you're on Intel, AMD, or whatever. And then we have .x86, where when you target this one, well, you equally don't run on ARM anymore.
We do have the whole is supported or whatever we settle on as like figuring out whether it's supported on that given platform. Like there's no guarantee of commonality. Like you put something in this, it may not be supported on your platform.
Mm-hmm.
Sure. Okay, vector 128. What I'm saying is that we don't have an x86 vector 128 and an ARM vector 28. But yes, it could still be not supported. Yes. Fair.
So the suggestion, if I'm understanding correctly, as far as namespace goes, it's system runtime intrinsics. Okay, so.
Do we want to put something other than intrinsic, processor intrinsic, or hardware intrinsic?
But what other intrinsics are there?
Intrinsics semantic.
There were some others.
So, for example, vector T has intrinsic functions, right? So those are intrinsic to vector T, as opposed to intrinsic to hardware intrinsic. So that's one example.
But related.
Related, yeah, and I think usually when people say intrinsic, it's meant to imply hardware intrinsic.
I think adding more words to the name is like splitting hair. Like it's not gonna help anybody except for like ultimate experts who decided that it's a bit more precise.
So
Well, I also feel like to me the high order bit is not so much whether it's hardware or not. The high order bit is that you expect the runtime / the AOT toolchain to know what to do with it, right? And some of them may actually not be hardware. They may actually be the runtime does something magical here, right?
That is true. Even for C, C++, there are intrinsic functions that don't do anything, but they are there as a glue, right?
The definition was meant to include platform, not just hardware. I mean, it could be like, hey, this is a Linux only thing.
Yes.
So the word intrinsic might be a bit of a misnomer.
Yeah. Also, like we usually use namespaces for organizational purposes, and if the name is 100% correct, what ends up happening is you cannot use the name a large number of times, right? So if the name is like good enough, like 80% correct, like it's probably a better name than one that tries to be super precise. All right, so I think then we discussed that one to death.
So I have a question about the is supported properties. So, or methods. They don't take any parameters, so they kind of imply that this whole API, like vector 128, will work or won't. Right. What happens when we want to evolve the API? And for example, there's vector 128, and it's implemented both on Intel and some other processors. And initially, the support, works for the whole type, but then we want to add one more method. And this method can only be implemented on one of the processors.
Then that method should be in hardware specific or vendor specific namespace.
How do these version is another way to say it. So like you have a spec that defines this instruction set today, and then someone says, hey, we need
how do you evolve it?
Yeah.
Right?
Yeah.
That's a good question.
So I guess AVX also has versions, right? Similar to, SSE clearly has versions, but there was the idea, I guess, that you wouldn't have like a single SSE type. You would have SSE and then SSE2 and then SSE3. So I guess the idea is that assuming the spec is final at some point and then you get another version of the spec, you get another type. I guess that's how you would work.
That would be how I'd assume that.
Yeah,
you never change an opcode.
So vector 128 is tied to some version of SSE.
Well, I guess this is why I think when we talk about these guys here, let's first talk about these ones because I think these are easier to understand. My understanding is, so if we look at SSE2, for example, at some point the SSE2 spec was finalized and there's like, I don't know, let's say 100 different opcodes that make up SSE2, right? And then at some point somebody says, okay, we need more opcodes, and then SSE3 comes along. So you would have a new type called SSE3, which adds whatever opcodes are added in that one. And then in your code, you probably end up calling functions on SSE2, SSE3, and SSE4, let's say, and then a dual responsibility to call the right is supported method.
Okay, so I think I understand. So basically, vector 128, we won't be adding operations there. The is supported method just says, do I have 28-bit registers on my
That's what I would think, yeah.
I see.
So, can you hear me now?
Yep, we can. Let me just raise the volume a bit, but yeah.
So the concern that I have is, I get that vector 128 is either supported or not, as in either you have hardware vectors of that size, but it seems like the proposal has indicated that, we're not going to have an all or nothing support. This isn't going to be implemented, and then exposed in one big chunk, even say SSE2. So how do we evolve this over time? How can we expect people to use something that doesn't have all of SSE2, but we expect to add things over time? It doesn't seem like, I get that we don't necessarily want is supported on every little intrinsic. On the other hand, I don't know how you get from offering a few to offering everything.
So what does it mean to not support whole SSE2? I understand processors either support SSE2 or they don't.
Right. So for this
point is us.
For this case, I think this example is pretty clear, which is like the listed ones are supported based on that is supported on that type. Like when you add a new API that is supported in that type either covers it or you have to put a new type in with a different check.
No, but I mean, I think what Carol is saying. So let's say, I don't know, SSE 6 comes on, right? Let's say it adds 150 operators. Are we then basically saying we can only add the SSE 6 type if we immediately expose all of these operators? Because if you only do half of them, right, and then later on we do the other half, then yes, the processor either supports all of them or nothing, let's say. But the problem is then, well, if you coded against our version of the library, but then you use an older version of the runtime that didn't actually have the intrinsic for the other half, then there's no way for us to indicate that.
Right.
Which is why
yes, thank you. That's exactly what I was getting at.
Yeah. So my response to that would be I would treat those types as not something that sit out of band, right? I would say they're like literally like with the runtime, and like if your hardware supports SSE2, you will support all the methods on her. And if we add more methods, then we can only add them when we do the actual intrinsic work in the runtime as well.
So would we say then that for like SSE2, you'd have to list all the APIs and then just leave the unsupported for the ones that are
the ones that you don't want to implement right now, you just don't have methods for, yeah.
Yeah, basically, it's a combination of which methods appear in the type and the is supported return value. They tell you almost everything. And then, as Imo said, they are not out of band, they are tied to the runtime. And I think it will work.
So all the IL compilers, the JITs and the AOT compilers all have to be in sync. You either support them all or you don't. Is that what I'm hearing?
Yeah, because otherwise I think we make our customers' life like incredibly complicated and ourselves too.
Yeah, this is already stepping in the territory of it will be hard to write portable code.
It's like anything that touches this isn't portable.
We won't even create net standard refs for this to share it. Like even if we have the exact same runtime support between desktop and core, eventually we still wouldn't create an easy way for people to use these in a single binary.
So the other thing that I would say is like I think we can still create a world where we have different runtimes that support different levels of SSE2, let's say, right? Where we say, you know, our core CLR implementation, let's say, has 100 methods, and then our AOT implementation only has 50 because we were lazy, let's say. So what we would do in this case, we would say when you target UWP, where you have to use both runtimes at the same time, the developer can only see the 50 ones that are basically implemented on both core CLR and AOT. And it's our responsibility to craft a reference assembly that has that. And then if we add to .NET Standard, same thing applies. You have to take them whole or nothing. Like it's basically, I think this whole like how much do we support, I think is already handled by the normal version rules of the framework and how we write portable code across them.
Well, so let's go back to that. It's not going to be .NET Standard. I can imagine if you're careful, you can write portable library. Because you do a query first whether something is supported, and then you have a fallback that is implemented using some other means.
Yeah. The reason why I said that is because of the progression of these APIs, how they grow, and the linear nature of .NET Standard. So consider, like, you would, if you put these things in, and we just had this other statement about the JIT having to support, or the runtime having to support all or nothing, you might end up creating a roadblock for a framework where it can support all the BCL types that are in .NET Standard, but it's like, no way, Jose, on these intrinsics because it's doing some weird, like, I could see UWP being there. Well, maybe not. I guess I don't know about how, but it feels to me like it's a very different problem where you wouldn't want to combine those two things on the same versioning dimension. Create these roadblocks for people. I mean, if we want to do that, then we probably need to think about how we would.
Well, so that was the comment from Tom. Like, what is it, right?
Yeah.
And so on.
And the whole image is completely wrong.
Yeah, let me see if I can find it.
The bottom part is backwards.
Yeah. Let's see where I saw this.
If it went into .NET Standard, you'd essentially need and is supported on every single method, wouldn't you? to say whether the runtime supports it.
I'm just.
To start subsetting, we could have this thing return false and then more granular ones return true.
Well, as long as we can clearly describe the contract. Let's say I'm writing portable code, I call is supported. What can I do? When it returns true, what can I do? And it returns false. I have to write a fallback logic. As long as we can describe the contract, yes. But the more of these query methods we have, the harder it is to describe the contract.
Sure.
Because you're like, oh, it's separated, returned false, but maybe it's not really false. Now I can query some individual.
Well, you would just, if we added more granular ones, you would just use the most granular. Because it would always, it would never.
What code you would have to write. Let's say you write, some code that vectorizes something, right? And you call like 7 of those methods, right?
Yeah.
Now your entry point is and then God forbid you change your method body and you didn't update your query checks accordingly. I think that becomes like at some point it's like
So
it just depends on.
Do we want to say that this is like some kind of like more policy thing? Like we've talked about being more tactical about what ones we support, but maybe we should do more complete, like, hey, let's fill out all of SSE2 and get more of that chunk done, and then the is supported becomes not as confusing.
Yeah, I think the what we're trying to get at earlier is I think the only problem with the designers right now, if you would add something to the .NET Standard or even to the runtime, it's the same problem really. Like if somebody wants to support part of SSE2, like we have no way of doing that. Right. The only way we're doing it is to say we only expose part of SSE2 on that particular platform.
Right.
And I think that's the only real problem, but I think that's, to me, it's the same as with any other API we have.
I think it's fine. If somebody cannot support the whole set, they should just return false and basically pretend that they don't support anything. And then the fallback logic kicks in your portable library, and it's much better world than complicated queries.
Yeah.
Nobody will be able to do that.
But maybe we should add to the sort of overarching design that we prefer, at least policy-wise, prefer more complete types. Don't specify a type and then leave half of them unimplemented and make this sort of ambiguity around these.
Right.
I think that's the best way to go.
I actually like the idea of saying you just mirror the specs, right? And the specs are designed to be all or nothing things, I think.
Now, this impacts you guys, any contributors more, because it sort of says that you want to do a whole tranche at once.
Right. Yeah, that's the concern, because these are not small sets, right? They're fairly big. Right. And I think the is supported is, the way we envisioned was meant to say, is the underlying processor supporting this ISA, right?
Okay.
So that's why we have one per ISA set, which is represented by different classes.
Right.
So that makes sense from our point of view, but I also understand that it's when the programmer says it's supported, it means
I can call everything on it.
Yeah, it's hardware supported and the implementation exists for it, right?
Yeah.
So.
But I still think we can grow the types. I don't think what we're saying is that you need to, when you add a new type, you have to add all the instructions from the get-go. All I'm saying is that every single time you add a method, you have to make sure you don't regress the all or nothingness of the is supported.
Okay.
That's all it means. Yeah. If you add a method, you immediately have to add the implementation across all the runtimes.
Does that mean that in typical practice you have to do, the top level check you do is to check a version on the runtime where you expect these intrinsics to appear?
No, because the way I would handle this is if you're on a runtime that supports 60 methods, you will see 60 methods. If a runtime only supports 40 methods, you will only see 40 methods. You will not see the other 20.
Okay.
Because we will craft the assembly surface area to match that.
Because you see, your concern was about like, it's costly to add them all. What we are saying is not that you need to have all the SCC instructions within this type immediately the first time you ship. You can do it in lockstep, kind of in steps, correct? The thing is that if there's a method and its supported returns true, it has to work. It cannot be, on this particular runtime we didn't yet have time.
Right.
Yes. So if you use one from a future version and it says, hey, I can't find this API, then just tough luck. That's just the way it is.
Well, if you use previous version of .NET Standard, it has less methods. They just don't appear in, you cannot call them. The front-end compiler will not compile, and it's fine to not support it. But if the front-end compiler does compile,
it has
and its supported returns true,
has to be there. Has to be there. Okay.
Makes sense. I think if you scroll down, we have an example of how you would use the supported, right? So here's one.
Yep. And then I guess what we were saying is like if it's literally like this, the idea would be that the JIT would literally just strip essentially this context if I don't have AVX2 supported, right? It's not that you blow up with missing metadata or anything in here, right? Like the idea is that we would just don't use the code block and then
it will be eliminated by the JIT.
Yeah.
Yep.
And so how will it work for AOT?
You'd have to change you'd have to do some magic to say the is supported would turn into some kind of like hardware or CPU ID check, and I don't have the full answer on how that looks yet.
There was some discussion about that and concern, right? And one of the things that was suggested is that the AOT compiler could compile all the code path, right? And then basically, have a small runtime dispatch at the beginning, basically, sets things up so that when it executes, it can find the right path. It's not so simple, but I think it can be done.
Like potentially some optimization that doesn't exist yet.
And you might want to have a flag if you know you're going to run it on the same CPU to get rid of that.
So I was naively thinking that AOT just means you basically do what you would do at JIT at AOT time, which means I compile a particular architecture and then I cannot light up on you.
But that's like a new kind of thing where you'd have to put in like, hey, I'm targeting this processor at this step, kind of thing.
I don't think we want that. What we want is actually in C# you write if, else if, else if, else if, then AOT compiler emits instructions that valid on the platform that the code runs on.
But you still
since you never hit the code path, then
that's the never hit the code path is the complicated part.
Yeah, exactly.
Like, how do you manifest the if else that would be easily handled by the JIT at runtime when it knows the platform into, hey, I have like a general check for a platform that says, okay, I'm going to call your capability oracle, and then I'm going to ask some questions of the capability oracle that essentially will mean that I can return the right thing for, like, you'd have to rewrite the is supported into like, go check the oracle to get this.
Are there any execution environments where we have checks that prevent execution of binaries that have invalid instructions? Like, for example, I could imagine like in the Windows App Store, there's a verification tool and it would just, doesn't it like inspect the binary and says, hey, you have some weird instructions that...
One of the things you want to do is the same thing you do with the C++ runtimes, where you actually have the processor-specific implementations for different things. And so your library will have code that may not run on your processor.
Okay.
So you'd expect that to still work because you want to basically ship that library with all that in it.
Well, that's usually more like policy. Like, I mean, I would expect an AOT toolchain to support then either mode. Like, either say I lock my specs essentially at the time, and then the App Store policy is just that, yep, we tell you what the minimum is that you can require, and you cannot light up on your things. And then that's just the way the App Store work.
I think the is supported, that could be sort of taken into a static. Sorry. read-only static in IoT, but I think if you're targeting IoT as a developer, you'd probably have to be more coarse in your routines. You wouldn't be able to, do an is-supported check around every function, which you'd probably get away with in the JIT time because of the branch elimination. Whereas the IoT, you'd have to say, here's a large block algorithm that is supported on AVX. Otherwise, use this algorithm.
This was discussed in the comments of we can put the CPU ID check at init of your program, and then that sets
supported at JIT time, and then here's the implementation that is supported. And the developer would have to provide both, and that seems to be hard.
I agree. Yeah.
The call seems to be cutting out for me, but I just want to say I think that maybe not immediately, but over time we should really expect that an ahead of time compiler should be able to aggregate the checks so that the developer doesn't have to do unnatural acts to coalesce the the functionality into large enough chunks that we should expect a static compiler to be able to do that for them.
Yeah, I think this is a solved problem for native compilers, and it should be solvable for AOT as well. And we should be able to just write natural code with if-else and have it optimized by the AOT without us having to worry about it.
Yeah, I have to be honest, I don't quite see the difference between JIT and AOT in this picture, because it seems like it's basically like, can you isolate the blocks, right?
So I'm actually just thinking about how the is supported is implemented, and I'm not sure it's solved for native compilers necessarily. Like if you had one implementation of is supported and you were just checking a bunch of global Boolean bits and they were known to be constantly set at the init time of the program, you could do a bunch of optimization. If alternatively, these things were like compile time constants, runtime constants that the JIT consumes,
right,
like not CPU ID bits that are in some static,
right,
then you would optimize them differently, right? And the kind of operations you'd have to do in the JIT to fix it are different.
So my naive understanding was that basically is supported is not an actual method. It's based in Intrinsic as well, which JIT may replace it with a const.
Right.
And then AOT may replace it with a CPU bit flag.
Right. So, and that was the point I was sort of getting to, is that you would then say that providers of the API would have to be like, hey, here's my implementation to map for the JIT, and then here's the one for the AOT, because the sort of strategy of figuring out whether it's supported or not are different.
But Russell, this is compilers. So I get that. I agree that this is a solved problem in general. I agree that in specific, this is something that you would not expect just any old static compiler to suddenly be able to do. But a static compiler that understands that this is a runtime constant should be able to see that I am checking this runtime constant, in multiple places and effectively aggregate that. It knows it's a runtime constant, right? It knows it's generating code that will eventually run on a platform. So I'm not sure this would, fall out in the sense that if we ran this through the static compiler today, it would be able to do that. But it's something that we should expect over time, and it would be unfortunate to see, multi-versioning of code because the developer has to do this themselves.
perfect.
So the Hangouts is the version of Lincoln.
I think it's actually not linked. I think it's the roundtable.
It's multiple rooms though, so maybe it's IT.
It may also be just the USB driver. Can you guys hear me again?
I can hear now.
Carol, how much of my qualified agreement did you hear?
None.
Basically none of it.
None of it? Okay. So, Carol, I agree if it's constant, we should totally expect our toolchain to get it. It's you'll also agree that it doesn't do it today, and that there's some wrinkle with how one represents it ahead of time and how one represents it at runtime. So it's just sort of like sorting out those facts that I'm want to make sure we get to. But like all told, yes, I mean this is not like impossible to do. But it's not going to fall out today.
I agree, it won't fall out. I think it's a lot closer to falling out than it is to impossible.
Yeah, I have to be honest. Like I still don't understand the difference between JIT and AOT. Like I mean, can one of you summarize what the difference is in terms of complexity of the supported stuff?
So when the JIT gets the information, it's going to make a query to the runtime that basically says like, okay, whether this CPU ID has been run, and then you guys are essentially going to put some intrinsic in there that checks those bits. And whether that information is not going to be available in the zapper when it runs AOT, because AOT is not going to know what processor you're going to get to, which means you need to actually change the implementation of that intrinsic to call CPU ID, surface it up, and then do whatever processing to return the right value for is supported as part of the program, rather than as part of like the runtime automatically does this for you when it starts up.
So what I was thinking is basically in JIT you would literally physically remove the things that are false, right? Because
that's true. I'm talking about just that's a second step. I'm talking about just figuring out what false and true is in this case.
It's true, but I'm saying like for AOT, isn't then the behavior you basically just say, you replace this with whatever method you have.
Yes.
And then basically you just keep generating the code here, and then this whole block either executes or it doesn't.
It's
right?
figuring out what that replacement method is.
I mean, is supported for AOT and the JIT is fairly straightforward because it's you just do it at startup. But the issue I see is if you have a bunch of if else's in a tight loop, then on the JIT it's going to remove everything, and you're just going to have the most appropriate fastest method. Whereas on the AOT, you're going to have unless you're completely replacing whole sections of code, you're going to have a bunch of fall through ifs that you'll run through and then do a loop, bunch of fall through ifs.
As Carol said, if you had this constant data, even if it was a runtime check, you could do all the like unswitching of the loop and all the magical stuff to essentially have the JIT get you back to code that you would have written.
Presumably you pogo it on the comment.
No, not JIT, the JIT, the AOT, right? This is where you look at this and say, I know this is a runtime constant, therefore I'm not going to check it inside a loop. I'm going to multi-version the loop. And then you say, oh, look, and this loop is inlined into this other thing. Yeah. And so I'm going to multi-version this other thing. And, this is not rocket science. It's a solved problem. It's not in this exact form is it solved, and certainly not by the existing AOT. But this is not hard.
Okay, I think we can move on. Because
wait, that sounded like Carol was the low bidder there.
Right. Let me just quickly scroll through that. I mean, like.
So one thing I kind of like small API design. Like there's a bunch of identifiers in these APIs that don't follow our naming guidelines. I saw like acronyms and stuff like this, and I don't know.
So like it's just go this top to bottom. Like this is basically just general purpose vector types, right?
Yeah.
This is the only tool that we have right now. Like is this proposal complete essentially?
The only we have right now. Well, Sans 512, ADX 512, but we are holding off on that. I mean, we have to learn to walk before we can run, right? So,
the one question sort of I wanted to make sure we put on the table before we ended up after the hour is Roslyn going to be able to give us the constant?
The immediate.
The immediate parameter? Like, this really has to be an immediate. Like, it can't be.
Scroll down on the immediate.
Yeah, there
It
is
just
a
looks like top to bottom. So my first question here is, how do I ever get a value in this thing?
No, don't work top to bottom because I'm leaving in 10 minutes.
Okay, then do the other thing.
Go to
the immediate piece.
That was the IMM stuff.
Yeah.
There.
Oh, there we go. Sorry. Okay.
Like,
I mean, can we do it? Yes.
Can we do it?
Should. That's like where are these functions going?
Down in Intrinsic, wherever Intrinsic.
What library?
So this is in the encoding of the instruction.
Right. Where are these APIs going to add?
So I think
as core lab, sure.
Okay. Yeah, probably some core thing.
Because if it wasn't in this core lib, I was going to say, could you do an analyzer?
It's required to be in private.
Right. If it's required in private, then we'd have to do something.
Is this like an attribute? Like there's. Tanner always says that this is easy. There's already a pattern, something or other, and you could do some.
I will tell you, there is a universal easy thing for the compiler to do, and it's to say no. Everything else is hard. Everything else is hard.
What I was specifically referring to was we could use the modrec pattern. And if the compiler supported the modrec, I don't even think it would need to go through LDM for that. Only if we added a new language keyword.
Let's say 2 words. Overload resolution. It has to go through LDM. Because it impacts overload resolution. Because I think I know how we would implement it. It's not a ton of work, but
what's your feeling on risk and like
not bad. It's mostly we would probably do modrec, but we still have to decide basically. It would probably end up being a modrec, but so to be clear, like modrec is a solution. I know that gets suggested a lot. It's like how, like, what is the runtime going to behavior going to be when people get this wrong?
The JIT's going to be like, oh my god, I can't encode it. Run.
Because, like, for instance, there's no way to. So even if we did modrec, F# and C++ don't care. Modrec, they do not implement modrec the way it should be implemented, which is if you don't understand modrec, you should never use the symbol. But C++ has some definition of modrec. They understand the modrecs they admit, generally, and F# just ignores them.
Okay. Well, if they're wrong, then the JIT's going to basically fail to generate code.
Yeah, if we implement it, it'll be VB C# and it will work the way it works, the way it should be working. But it will. Okay. You are talking about, like, if you want completeness, we will have to do some work for F# would be different work because they would
I would assume in the JIT path that when we implemented this, if it came in and it didn't conform, we'd throw platform unsupported just like everything else. Like, look, you just gave me garbage. Like,
I wouldn't say platform. I think you
or whatever
invalid.
The invalid.
Yeah. You should do invalid op because that's a better one. But you would need work in other languages. C# and VB. I don't know. It's not terrible. I'm sure we could work something out there. Probably not use const because we have plans for that one. But maybe an attribute that we could lower it down to force literals, and we could then do what we need to do with it.
Does VB and C# do they honor modrecs correctly?
Yes.
So it's just F# and C++
that we're aware of, because to do ref read only, we're using modrecs. And we actually, in a process of validating that, we found out that C++ and C and F# don't implement it the way that we read the spec, at least. Don has said he understands they don't do that, and he's willing. I think they're willing to accept that for F#, but it's just work someone has to do.
What do you mean? They're willing for F# to change the design so they start rejecting code, or is it like they just are willing to blow up at runtime?
But Don was willing to basically. The changes we proposed, I think, what my memory of reading through it is Don seemed open to the idea of doing the work in F#, but today that they understand they do not honor modrecs. I could have those details wrong. I'm sorry if I do, but that's my memory of last time we talked to Don about this. And C++, I believe, only recognizes and honors some modrecs and some mod ops. But yeah, I mean, it's if we did monorec mod off, it has some implications, but yeah, it's not terrible.
Yeah. And I suppose you would just use C++ const modifier too, or
no, because they interpret that differently. Because C++ const does not necessarily mean literal; right? It means const.
I see.
This is different because it means what they need is literal.
Yeah.
Which in C# const meets the literal requirements, but it's but in C++ const is just a way of saying non-mutating, hopefully. Hopefully, if no one lied or used a mutable keyword.
Yeah.
It means it's supposed to mean observably immutable, observably non-mutating.
So why does it have to be literal?
Because that's just like think about what the JIT's gonna do. The JIT is basically gonna, when the JIT sees these intrinsics, it's just gonna map them to straight up like assembly code. And the assembly instructions here require a literal to be in these places. You cannot have a computed value like a register. So even if we put it into variable X, the hardware instruction we emit has to be have the exact literal.
The immediate goes to the instruction coding, so you could require optimization to say like, oh, we can figure out it's a constant, but then you're requiring optimization for correctness, which is like no bueno. The immediate itself has to appear in the encoding.
And the alternative would be to basically for every. No, we couldn't pass. We couldn't generate different kind of blocks and then just call them. It would be horrible. Yeah.
So a good example is you mentioned like a vector, 256, where you provide a bit mask that shows you how to swivel arguments. Now I tried to imagine how this would explode when you try to do that. That would be like. I think it's a non-starter. I mean, the only option that we have is to say, if you do it wrong, you blow up, right? Just tell you don't do it like it works. But I think that would be a pretty terrible experience.
I think it's so easy to get that wrong. It would be great to have compiler support for it.
It would be a new concept in C#.
Yep. Which is why, like, if there's a way to sort of like make it an attribute and constrain it to this sort of context, like, I don't think this is common. It's not like I see this as a big cross-cutting thing that's going to get used everywhere.
Yeah.
Like, I don't know how to solve this in a language sense, but this is not sort of general feature.
Yeah, that's why I'm kind of surprised that Jared was like, oh, that should be simple, blah blah blah, and I'm like, that seems like a completely.
Yeah, but then you said it wasn't that hard.
Well, it's not the worst because it works. It's it's easier for C# because our definition of const already just happens to meet what you need here.
Okay.
So we can very easily say, is this const? Yes. And then in our trees, we know what the value is. We can just omit it. Like, it's not, for us, it's a simple check. The complication is import and export emit data and deciding how complicated, boring overload resolution problems.
And I would add to it additional complexity in the language. Now users look at the signature of the method. What the heck const parameter mean?
Yeah, we wouldn't use const. We would put we'd use an attribute. I don't think we'd use const because we have language proposals that reuse const.
I see. So you would just put an attribute, and then if somebody calls this method that just says byte control, you would.
And it'd be like an attribute
error or something.
It'd be like
argument blah must be a constant or literal. Essentially, would be like the error. But there are some little subtle things. VB, I think, might be harder, but I'm not too worried about that.
Among the people that use Intrinsics and VB, it's probably very small. I'm venturing a guess.
That's always a bad way to bet.
You put your money where you put your money.
How small did you mean? I'll take
There's exactly 6 people that
on the
F# doesn't have any extra limitations of C#, right? It's only VB that's also one.
Yeah, I don't know. F# though, I'm not sure what guarantees they have around C# hard. If you have a constant, it's a literal. We know.
Yeah.
I don't know what guarantees F# doesn't have, and I'm not sure but we have to. just take it up the F# team, let them know. F#'s usually really responsive. If we did Intrinsics, I'm sure they'd have a PR out within a day or two to make it work too for them.
Okay, so hypothetically, like what wave of
not 15.5?
Not 15.5.
Unlikely, unless you guys really want to push.
It would we already have the ability to incrementally add these, so we could potentially avoid the problem.
We basically have to do foundation. Like we can only make compiler changes and foundational updates, and so 15.5 is the next foundational update. That's November.
And that's too fast.
We're pretty tight on that one right now and somewhat overflowing. Then foundational update after that, though, we would have potentially room to do something like this.
And that would be Marchish kind of time frame?
What was the question?
What's after 15.5, 15.6?
I don't know if we've established dates for that, but I don't know if that's. I don't know what we haven't said about it, but the next foundational update. Generally, they're coming at 3-month intervals.
Okay.
Generally.
That seems reasonable.
By the way, Jared, before you leave, we need to do the native ints.
What do you mean?
What? Not now. Like, what are you talking
about? Like, where am I going?
Am
I being fired?
No, you're not. I meant to say that you mentioned something about already being booked for the next foundational release, and
just for November. Okay.
But when are we doing native ints?
This is off topic, right?
That's what I said. It's a tangent, small tangent. Before he leaves.
Oh, I think.
Because you have 1 more minute, correct?
Yeah,
or you just wanted to discuss this first, and you told us that.
Sorry, I have to go to war now.
Which one?
Which war? .NET war.
So my other question is on this const thing. I think we also talked about in the past about there's certain bit patterns that are required. Do we care to enforce that?
What do you mean bit patterns?
There's certain I think for bit filling, for example, there's certain patterns are valid and certain things are not valid, right?
That I would leave to the JIT implementation, and that's like a buyer beware thing.
It's a what?
Buyer beware thing. The person who writes it, we enforce that it's a literal. You didn't sort of accidentally screw that up, but if your bit pattern's out of whack, the JIT's going to complain.
Right.
We can't make this completely pain-free.
Possible to emit an attribute as modrec, or do we have to implement language support for that?
We can. What we might do, frankly, is since this is kind of controlled at the MS core lib level, and we have a little more flexibility in how we generate the code there because we can do post-processing or something, what we might do is just force them to have them add the modrec there, and then everything falls out, and then we just basically, we don't have any, we can support a modrec, we can support the semantics of a modrec without giving you a way to add it.
Okay.
That's another possibility for us, is to say if this modrec is present, we know what it means, but we don't have a way for you to put it down there for us.
Okay, Emo, where were we before I forced you into a...
I think we were just at vectors and we're slowly starting to scroll down.
Okay. I see you scrolling up.
No, we were past this.
Yeah, intrinsic functions. So I think we talked about the high level idea, which is each architecture gets its own namespace, and then different spec versions are different types. Which I think we're also already agreed on.
So, for example, here is the naming issue, AVX. According to our casing guidelines, it should be lowercase v and x.
No,
trust me.
I know that's the standard. I know that's the standard. It's just one of those sort of tough ones.
What's tough about it?
It doesn't map at all to the other documentation that exists in the world, so it's this weird impedance mismatch. there's already an AVX in the world with giant books, and people use it all the time. Like
and casing would
same like SSL.
Yes. And SSE. We already have some APIs that have SSE cased properly.
So I think casing, I'm not really up for negotiation because that actually fucks over people pretty badly if we screw this up. But I do think there's a higher order discussion on what to do with certain abbreviations. But I mean, like, this is like, for example, let me get my mouse if I find it again.
On casing, you could compromise by talking about x86. Is that a...
well, it doesn't
I
really
suppose that would be a big X.
That's SSE, right? So I'm not sure I understand the point, Ben. Like, what are you saying?
No, sorry. I mean, it would start with a big X, wouldn't it? So it doesn't matter.
Yeah, it would be. Yeah, and the lowercase 86.
Luckily, we don't have lowercase numbers.
No, but I think the question really is like this is the C++ intrinsic, I suppose, right?
Right.
Yeah. So we can't quite map that to .NET. That would feel like super weird if we would use these tie-ins, right?
Try not to.
Yeah. And so that's why we call them just add and then be done with that. Are we fine with that general approach and like having like, for example, things like here like add subtract, for example, where
so C++ will use add sub or uses add sub.
Yeah.
You're saying we're spelling it out as add subtract.
Yeah, I think that's fine.
That seems fine. I mean, I honestly think just casing.
And I like the convention of like putting the comment in there just so it's easier for people to map over.
Yeah,
that's enough.
I mean, you could always have just a simple interop wrapper type that converts them for people coming from C++ if they just want to dump it in, but have good names in for this actual C# ones.
I think wrapper type like that does that, and also wrapper types that do software implementations and stuff like that, if we decided to do them, should probably be not in CoreFX, but in a third-party extension library. Because I wouldn't imagine CoreFX would use it, nor should most people be recommended to use those.
Yeah.
The question I have is, like, let's say, even if we were to do a wrapper library, which I'm not convinced we would, but let's say we would, do we actually get the performance you want? Because basically, like, you rely on full inlining, right?
But yeah, the JIT would just dump the method, wouldn't it?
Like this already is like you don't have a call here. You just get inline code that's like.
Well, but if you wrap it in a library, you would have a call and then intrinsic.
Yeah.
And yeah,
the inliner should
be able to deal with
inline it. I mean, cross assembly inlining, like you'd have problems for any of these that were exposed at assembly boundaries. So you'd not want to do that. But yeah, or you'd also want to basically tag it with like force inline, like no, really inline this.
But it would be cross assembly for the most part. Because the user is calling this thing, and this thing comes from some library. So you rely on this thing being inlined at the user's call side. And I'm saying, is that something that we would be willing to sign up for? Because otherwise, the wrapper library will have terrible performance. You have a method call for every single
the one that you get much better performance out of the JIT because it does this kind of inlining naturally. AOT solutions, especially when you have ready to run, you want versioning boundaries.
Right.
You'd get bad code, and you'd have to rely on something like tiering coming in and fixing it for you after the fact. So it'd start up fast, but you'd get crappy overhead, and then the JIT would have to fix it.
But whole program, if you support whole program.
Well, JIT in general is whole program already.
Yeah, I'm saying about AOT.
If you supported whole program and you did away with the versioning boundaries of ready to run, you could do it. But if you want to do versioning, you have to.
What's the versioning issue if you do?
Versioning doesn't allow you to inline across.
Versioning. I understand, but if I do whole program compilation, static linking everything, there's no issue. You basically
right. If the managed linker came in,
you just remove the call, correct? Like
the managed linker comes in, mashes everything together.
That's not how we ship.
Yeah, but that's not how you ship.
I know we don't yet have this feature, but
I think UWP probably could just help ourselves by saying if you would have a wrapper assembly, we would just treat that as user code. Because we probably would do it out of band anyway, and then you have like essentially two parts, but you have the runtime that is digitally two, and then this thing is just the same as any user code, and then we could inline the shit out of that.
So it's not a user library; it's a user C# file that you include in your program.
That
otherwise it wouldn't work. But
I think for cases where you wanted the library to go, you'd essentially have to do something like the manage linker to fix these cases and do the whole program. But then for typical code, you just have to rely on the JIT.
So people on the call, like, are there any strong opinions on we should provide wrappers for C++? Because I would go with we don't do that unless we are asked to do that.
No, I mean, I agree with Dana that it should be third party. You know, if you want a wrapper, then you can pull one off NuGet.
Yeah, that seems reasonable. Just write it down. We should follow our casing conventions because I think honestly casing is. I think it doesn't really fuck people too bad because basically what ends up happening if they spell AVX all uppercase, IntelliSense will still do the right thing for them. Like it's not like code doesn't magically compile, but if you have other errors in the framework that violate the casing conventions, then that tends to cause more problems.
Okay.
Because then people don't see what they expect, and then tools don't do it correctly, and all sorts of weirdness happens. But I'm fine with the name AVX. If any concern, it's just the case.
No, that totally makes sense. I mean, because I think if we spell it out too.
I don't know what it stands for.
Extension.
Good to know. I learned something.
Yeah, I mean, I honestly like the idea that they're all short and they're basically the specs. Because I think it's fair if the namespace looks a little bit ugly. Because we should do some reading before we start calling these methods. Right.
There's a load double quad DQU that is a bit so it goes load aligned and then load DQU. So I don't know if that's sort of a bit weird.
That's one of the few exceptions.
There is a example if you could roll down and that's roll down a little bit. Yeah, in this example code.
Yeah. So first of all, I think the load. So in C++, it's load U or load on a line. We are saying, and we can we are using load right now to denote whether it's aligned or unaligned, but we could name it load unaligned as well, and then we have load aligned, and then load DQU. So load DQU, that's kind of it's for double quad words. So we could. But the thing is, people who are using this Intrinsics in C++, they would know what they're looking for. So that's kind of the trade-off that we have to.
If you spelled it out, what would you choose? What would you call it?
Load double quad unaligned.
But would it? I mean, could it be pointed to a vector 256? I mean, that seems a bit weird that it's a pointer to itself, but it's kind of that thing, isn't it?
I mean, these are the things that actually give you values in the first place, right? You don't get a vector 256 otherwise. Well, I guess you could pretend that it's the same pointer, right? I guess that's there, but
you could do it with unsafe and a ref.
It's true. They're all struck, so they're fully working out.
So it could be a ref in an array, for instance, of vector 256. And you're loading to a register.
Anything that is not a pointer here? Well, as far as loading is concerned?
So pointer is emulated. Yeah.
And we use the concrete pointer type here for this intrinsics that take pointer parameter. But somebody asking maybe we should add the void pointer support here.
That seems problematic. I'm just gonna say that I'm gonna do Jarrett's like that's pretty hard. I don't know how that would work.
Well, my only concern is, I guess it makes sense because they're all vectors, but it basically means that you always have to be unsafe to get anything out of it.
So could we just use span here?
Yeah, that's what I was thinking. Either span or even ref would probably work, right? No?
Then if you have the data in an array, you just call array. If you have it in native memory,
span could work.
Then method signature is not unsafe. And
it could also return a ref to the vector.
I mean, the span's got to check a length as well, then, doesn't it, to make sure it's the right size. So it's you're adding an extra indirection almost, unless you just ignore the length.
So you're saying you make it more expensive? Is that your point?
Yeah, because you know, is it actually long enough to load into this?
Yeah, I think this feature is going to be almost exclusively used by library authors already working with low-level code, and so having ref or unsafe code is probably not going to be a big deal for those users. I think the people who have complained are people who are looking at using this from a higher-minded point of view, and I think if they want to write those libraries, they can, and they should just have to do the unsafe casting between the types they need.
So one thing we could do is just have overloads for both a pointer and a span. If you kind of want, the code to be a bit clearer because you don't need to have like unsafe blocks and fix the array and whatnot, you just pass a span. Otherwise, if you worry about the length check, then you use those and your code is a bit more ugly.
I mean, you could do ref byte, but it's really weird because you think of it. When I see ref byte being a pointer to a set of bytes, it also comes across as a single byte.
Wouldn't the common case for the span thing that we get rid of the bounce check?
Yeah, would you do that in all cases?
Well, yeah. I mean, it's not all cases. It would be whether it's common.
I assume we would get rid of the bounce checks on like in loops, correct? When you index, not so in this case. In this case, in fact, it would be a feature. Like my code is a bit safer, correct? Because I deal with spans. Yeah. And then if I worry about the overhead of the length check and I know that I'm passing the right length, then I just call this other overload and it gets rid of the check. At the cost of me now having to deal with unsafe.
Yeah.
I think load aligned would always have to be a pointer because you don't know its position if you don't have a pointer.
Sorry, I didn't understand the
load aligned, I think, would always have to be a pointer because you don't know its position in memory as whether it is aligned unless you at some point are dealing with a pointer.
Yeah, well, so I assume that the method that takes a span would have to fish out the pointer from the span anyway at some point, and then it would check whether it's aligned.
Intrinsic expansion with it.
Yeah.
But you only know that it's aligned at runtime when you're, it would be the wrong method to call. Let's say you'd have to do a check on, I do a few bytes and then I now know that my current pointer is aligned.
Which kind of is a problem with span today a bit. I would like to fix it. It's just, aligned on what boundary? I assume some of the vector operations, they require alignment on the boundary of the vector size, correct? Like 56 vector, it has to be aligned on 256. Yeah. So,
But you can't do that with the reference because the GC could move it.
Yeah. Because the GC what?
Could move it.
Oh, you're saying that if I see.
You only know that it is where in an aligned place if it's fixed.
Once you have to pin it and figure out alignment and that kind of thing and do the dithers, that's way more overhead than just unsafe. So
yeah, and at that point you've got a pointer.
Mm-hmm. I've got a proposal up for adding alignment for structs and various other types, but we'd have to have that before we could take that into account for ref or anything.
Yeah, I was talking with Jan about the issue that today when you allocate an array, we preserve the alignment. but only for
the natural alignment of the element type.
For natural alignment, not for like these longer vectors.
Right.
And I wonder whether that should not be a guarantee in the runtime as well. Like,
it's probably a lot of change.
With the GC moving of buffers around and these APIs that require.
Wouldn't that put a bunch of extra pressure on the GC because they'd also have to do like I've got this thing allocated and it has to be on this boundary. So when I move it, I've got to find a place for it.
I'm saying that they already have it.
You say that they already have it's based on the natural alignment, but you're essentially saying like I would have cases where array is natural alignment and then array is also spec align, and the GC would have to manage both of them. Yeah. That seems like a bunch of extra hooey that I'm sure the GC people would like to deal with.
Don't we already have some of that for system numerics vector, where we've got the special alignment knowledge of must be aligned by 16?
We probably have.
I think that's only when it's in stack, isn't it?
So we don't. I don't believe we align those ever. I mean, except on the stack.
Okay. Because you see, like these. I mean, these APIs. So in practice, how do you use them? Where do you have the data? You have them in some array. Then then you pin, then you check the alignment, and once it will be either aligned or not aligned depending on this code or the other code. I mean, that would be so hard to actually write code.
Right. Or you'd have to have it as part of a static thing that's already that you
or you allocate a bigger array,
yeah.
You pin it permanently.
Yeah.
You then find the alignment, you put the data in. This I understand the APIs are not the easiest to use, but that will be the next level of kind of trickery that you will have to know how to do.
I mean, the other question is pointers don't help you here, right? Like it's not pointers versus span, right? I mean, alignment is something that is generally a problem, right?
Yeah.
Yeah, but what I'm saying is this one is even harder because there are runtimes give you no guarantees about it. So unless you permanently pin or allocate it in native, the code is very wacky and inefficient potentially. Because you either permanently pin, which you have inefficiency in the runtime now, or every time you pin and check alignment, you have to potentially ship the data.
Well, no, you'd have a startup that you process longs, and then you process some bytes, then you process some longs, and then you hit the vector alignment and you move into your aligned code.
Basically, like when you write memcopy in C#, you would have to do the same tricks.
There's no large performance difference between aligned and unaligned loads and stores on
today.
Today. Right? So most people, I assume, they would just use load, right? Because there's not much delta between the two in terms of performance, and that makes it simpler. If somebody really wants to use aligned, we provide the APIs for that. But
what's the non-temporal one? Is it A?
NTA?
Yeah. Is that anywhere in there?
I think we do provide it. But again, it's something that
it's spooky.
Regular humans would not use, right?
Right.
Yeah. I think while Intel behaves well with unaligned and aligned, that might not be the case for all platforms like ARM, where I know there's sometimes stricter requirements around that, and they don't even support unaligned in some cases. So I think it's probably something that doesn't need to be decided today, but it's something that is going to need to be supported in the future. Just general enforcement of alignment for user-declared structs.
ARM is going the same path as Intel. It used to be a big pain in the butt and was hard, and now with the new architectures, it's pretty much handled by the hardware.
So, but how many cases do we actually have to get alignment on arbitrary objects on the heap? Isn't the most common case you have some data on the heap, you get it into a local variable. Local variables are aligned in our case, and then you just keep modifying your locals. So you basically get data into aligned, well then you stay aligned.
No, they only aligned on the what do you call it, natural alignment.
So you have a data type that's if these things have two doubles in them, they can be on the double alignment rather than on the block alignment for the larger thing.
So even for stack-based things, we don't have like
No,
arbitrary alignment.
no decal spec.
So another related issue. So I assume there's a method is supported in ABX. The differences in processors in terms of what they support, unaligned or aligned. Basically, will the unaligned always work when it's supported returns true?
Yes.
Okay. So if there's a processor that doesn't support unaligned, they won't support this whole type. Right? ABX spec says you need to support unaligned read.
But we should probably make sure that our naming is consistent across. Like it would be nice that, let's say in Intel's world, let's say load means either one. We shouldn't have a load on, let's say, ARM that basically says in the documentation what requires a line. Like at that point, you should
that's what I'm saying.
There's always going to be little stuff like this. Unfortunately, it's going to have to get looked at in code review. There's probably no policy way to make this happen other than.
No, but I think naming helps you with the code reviews, right? Like if load on ABX means either one, and load on ARM means requires a line.
Yeah, that would be
kind
bad.
of shitty, right? Then
That's not just a code review issue. Then it's impossible to write portable code. We are back to I do the check. It's supported. Okay, awesome. It's supported. Okay, load unaligned. Boom. Yes. All right. We don't want that.
I don't know if that's necessarily the case though, because they would be in different namespace, and I understand that if it's a common operation, they should have the same semantics. But that's really difficult to enforce, right? Because different processors will have different quirks, right? So add with saturation might be
how many bits?
One meaning in one, but not the same meaning in the other, right?
Yeah, I think it's going to be unescapable that there's going to be some drifts. Even if you had floating point, there's going to be like quirks like, we're IEEE compliant, except for that one little case over there, and it's going to be different.
All right, so going back to the names in some of these APIs, mem does not follow our naming conventions. Can we spell it to like memory or buffer or I don't know, something?
Address.
Address, yeah, that's right. And so did we conclude we are not adding overloads for span? I'm okay with starting with, like initially it's.
Yeah, I'm fine with that.
Or we could do like, we have span overloads for the unaligned ones, and so we don't have to deal with the issue of pinning. What do we want?
Or ref overload.
Sorry, what was it?
Ref overload.
Oh, ref. Yeah, I kind of agree with.
Start with this and then see where we get to.
So, yeah, the only thing is that now if we do add it to that standard, like waiting, and this one will not be out of band. If you wait, then it means potentially very long wait till actually somebody can use those. The by ref, somebody made this comment, I don't know who that was, that like ref to byte kind of does not imply that it's a buffer.
Yeah, I think Ben said this. It's unclear whether it's a single value or whether it's a set of values, but I don't know.
It only applies that if you are in C.
Yeah, exactly.
I mean, you get back a vector, right? So, I mean, that kind of conveys that.
Well, if we end up adding the scalar instructions, then it doesn't necessarily mean that. There's cases where you can say load scalar float, and you reference a pointer, but it only loads the 4 bytes and still returns a vector 128.
What to do for the remaining ones? Just use the same value or pad with zeros?
I think it pads to zeros, but I don't recall exactly.
Well, if we have that, then yeah, like good naming is key. So I mean, in that case, I would argue we shouldn't call it address or value. We should call it like, I don't know, vector or something to imply that it actually is a sequence of values, and then the other one is just, I don't know, value. And the other problem is because you're an unsafe, right? You really get like hot crushes, right? You don't get, line number 5, you're out of bounds. You get like, oopsie. Somewhere down the road, things exploding.
Could always come back to it in a later code review as an extension, rather than. I'm all for shipping early.
Yeah, that seems to be something there. I'm not too worried about .NET Standard because I think we'll first ref this on core and see how it feels, and then get from there. Like I don't know how the intrinsics are implemented. Like, how hard is it to go from a pointer to a ref or to span? Like, is this completely making this rewrite everything, or is it more like a mechanical?
Well, today, if someone wants to go from a ref to a pointer, they just have to use compiler services unsafe as ref or as pointer.
So I mean, on the implementation, let's say we change our mind later and say, oh, pointers are bad, let's go with ref of t instead everywhere. Like, how much rewrite is it on your side?
The expansion would have to change a little bit, but it shouldn't be
terrible.
Shouldn't be dramatic, but it will require like going and touching a whole bunch of places and making a mechanical change and then running all the tests.
Then I would say let's go with pointers first and then see where we land, right? We can change our mind later. What was DQU again?
That was what? Yeah. I will spell it out.
It's the
double quad word.
Double quad underlined.
Double quad word underlined.
Yeah, at some point I would almost say, like, to me the litmus test for expanding or not acronyms is if we expand. That's why I asked you, like, what would you expand it to? And then somebody who doesn't understand the technology, would they be able to say, oh, well, now I know what it does? And I'm skeptical that, that's something.
You went double quad underline, yeah.
It would just make it longer and wouldn't help too many people.
And we had the same question about the load. So would it be clearer to say load aligned or unaligned instead of saying load?
That's what we were sort of tending to that earlier question thing that you said, which is being more specific about
load.
But
this one I would say load is, in my opinion, better because actually load unaligned would be not the right description because it's both aligned and unaligned, correct? So it basically means I load anything. Like, you just give me data, I will load it. And if we add unaligned, some people may think that they actually have to call, this or the other item.
Make sure it's unaligned.
Okay. I think, and it's more general. It's like you call it unless you discover that you have performance issues because you're running on some weird hardware. And
to me, load implies aligned or unaligned.
And so then,
unless you tell me otherwise.
On ARM, would we only have load aligned, like load would just not exist?
No, load. Like I said, the most modern ARM architectures actually, when they come up, they set the bit that says, yeah, just deal with aligned and unaligned the same.
So
they don't require the same, the everything to be checked like the old days.
So when we implement this on ARM, we're going to say that's our baseline is the newer processors?
Yeah, most everything that's shipped in the last 5 years, which is forever, has this. Unless you're buying a really super cheap part, and then that's a whole different thing. And if you spend less than $1 on your part, and maybe you're not using core.
Yes.
Also, I think we had this discussion with Jan at some point, and he implied that it's a combination of hardware and actually the operating system.
On Windows, it can be. It used to be that there was actually the operating system on Windows for early ARM32 would intercept the exception and rewrite the instruction stream and then re-execute it and get the data in if you faulted.
Holy shit.
Slow.
Yeah,
slow.
That sounds really fast.
My program is working. Doing a lot of work, but it's working.
Any other comments on?
So I would add. I know if it's cost, why would we not add overloads for span for the ones that don't care about alignment? No, it's just like a method that basically pins the span and calls the unsafe method.
Because it would need a body where you check the span length, that the span length is the same or greater than the vector type you were loading.
Yes, we would. So I'm saying we would still have those that take byte star, and then we would have overloads for people who don't want to deal with unsafe code. And the overload,
but it could be a higher library. It's not necessarily the intrinsic.
Yeah, I think it can be a higher library, and the people who this feature is aimed for are going to be dealing with unsafe code in some capacity already, more likely than not.
So the thing you're talking about is the wrapper thing that does the check and does the span thing.
Right.
The JIT would not recognize that as a special thing that turns into a fixed set of instructions. It would do the low level. So you just re-implement the span version in terms of the low level.
Correct. The problem is that. Oh, what about the inlining?
You'd have to have it inlined. Like you'd have to rely on the JIT to do the right thing for the inlining.
But the JIT could then maybe hoist the bounds check that you'd be doing with the span.
You'd want. I mean, the JIT would not naturally try and be like, oh, this is a small method. Let me get it inlined because it exposes this nice property, and then it would basically try and hoist the check or get rid of it, and it would do the normal thing.
But I don't think it needs to be in, deep in core CLR.
Yeah. So if you wanted to put wrappers on this, I would from hey, how much effort is it to implement? You wouldn't want to double the number of methods that are recognized as intrinsic by the JIT, and then have them like, oh, I recognize the span version, and I stamp out this series of instructions, and then here's the non-span version. I stamp out this series of instructions. You wouldn't do that.
No. Okay. I was just saying that like adding those overloads to this library is such a small cost as opposed to having a separate library where we have to worry about inlining and people not getting it. And in general, we are now walking through BCL and adding span overloads for all unsafe APIs, despite the fact that many people already.
Where's the span overloads would be implemented here?
Yeah.
Okay. But they're not implemented, just for clarity. They're not implemented.
They are not intrinsics. They are just like a method that has a method body and it just pins the span and calls this intrinsic method.
Well, my argument would be like, regardless of consistency, the question: what feedback do you want? Like, if you want to get feedback on is unsafe good enough, I would start with only unsafe. Otherwise, you never get the feedback. If you're very convinced that span is necessary regardless, then yeah, I think front loading makes sense. Otherwise, I would say, well.
But does it go in this? I guess it does go in the same space.
You see, at that point, if you're putting span in, then I think you'd want like ref byte, ref this, because then you don't need to pin the span. You can pass it in as a ref, dangerous pointer.
Yeah. Like, I mean, how many load instructions do we have? Do you guys have a good handle? Is it like 20 or 30? Or is this like in the hundreds?
Definitely not in hundreds, right?
Yeah. Because my only concern is that we end up like tripling or doubling the service area. Like,
the thing is that I understand that some people, this is the only unsafe API in this whole set, correct? Like creating a vector. And it's such a pity that just to call a constructor, I have to have unsafe code, and everything else is safe.
Except the load we have load, store, extract, insert, or gather. Yeah. This APIs need to access memory, to load or store. Yeah.
And so the combined set could still be in the 100 set, right?
That's 100.
So
quite a bit, but not 100.
Maybe. Not 100.
Yeah.
So 60, yeah.
Maybe just 30 or 20.
Yeah, I see your point. You're sort of saying that every other API would be, for instance, open to Visual Basic, but actually creating a vector wouldn't.
Yeah, that's another thing.
That's actually a fair point. Like, you would completely block VB users.
And we would enable them if we just provided the span overloads.
those 6 users, according to Emo's estimation.
Really, they're pretty important.
But 2 of them already said they don't like it. Yeah. Really only.
Which in this design they don't like it. The unsafe one, I'm not good. I'm sure they don't like it.
How does F# do pointers?
I think so. It'd be really weird if functional language had pointers.
I'd be amazed. I mean, like, there's the other thing. I mean, I would be more concerned about F# than about VB, to be honest. Because the F# guys are more the ones that care about this sort of stuff. And that would be willing to go the extra mile. I don't see this being very common in VB.
We should ask. I thought they had more of a like refer to the array kind of style thing.
You could also just add pointers to VB. So that goes easy. So.
It would be Visual Basic in quotes.
Visual Basic ++.
What would we add then? We would do ref of t and span of t, just ref of t, or just span of t?
Looks like F# has native ins.
Ben wanted to do the ref of TA, and I kind of understand that it would be a bit simpler, but you can just pin a span. I mean, so I have no preference. I care about span of t because it makes it safe and.
Because you've been riding that hobby horse for a while now.
Can I just reinterpret cast span of byte to vector of byte?
You cast span of
Yeah, probably.
to vector of byte, assuming that the length of the span is the right length.
Yeah, because I know I can. I think. Geez, I wrote this code so long ago, and my memory is horrible. But I think I did cast spans of bytes to vectors of t, and it worked.
Oh, you can do an unsafe.
It requires unsafe?
No, using the unsafe library, you can do a ref and local ref. So you could go give me the reference to the first element in the array, and then cast that to.
Yeah, maybe. As I said, I kind of forgot.
I think we should consider the dependency when we use the intrinsics in MS Core. Yeah, in MS Core we cannot use the unsafe module, because that is in other managed assembly.
Yeah, you don't need to use. Well,
Span
is in
core. Yeah. So that would get you out of that. Although if you re-implemented the span version in terms of unsafe, you're still back with a circular dependency.
Yeah, but I'm pretty sure you can just basically call get dangerous reference and then get address of the reference. You don't need to use unsafe. Okay. Get the pointer.
Okay. And that sounds like we should have a span version.
Okay, I wrote that down.
We already did this one.
And we'll check if there's anything else that shows up. I think it's the only one we have, right?
So
compare vector 1 to 8. Does it need the 1 to 8 in MMM operations? I mean, is that just compare?
Oh, I mean, can we strip this one here?
So no, because there's also compare vector to 56.
But
wouldn't you be passing in a vector to? Isn't it defined by the arguments? Is what I mean.
Essentially.
I think there's a reason why we did it this way, because there's another comparison that takes in. Well, I have to go back and take a look. Do you remember why
AVX provide the compare instructions for 138 and 256 both.
Right, but it was not enough to have them overloaded. It had to be. We'll go back and check.
So we can add it to notes and try doing this and then just reply that you cannot for some reason. So I have a question about the enum, the comparison mode. It seems like the enum is a bit more general purpose than the other APIs. Like, can we imagine having at some point this enum be used in other APIs that are not related to vectors, just to floats?
I think the float comparison is ordered explicitly according to the immediate constant required.
I think the question is, can this be used outside of vectors, right?
Mm-hmm.
Yeah.
I don't think so.
I haven't seen them outside that context, but we can double check.
Yeah, I mean, the other question is like, what happens on ARM, right? Like, if we end up having more or less the exact same enum, just ordered slightly differently.
Should that be outside of the x86 namespace?
Yeah, that would be unfortunate. But at the same time, I don't think we want to order them.
Maybe not, because this value depends on the encoding of Intel.
So you're saying if we basically, if this enum was could be used somewhere with some other architecture, we would just have a copy of the enum. We would try to keep the names the same if they overlap. Otherwise, okay.
Yeah. I mean, in theory, because it's a constant, you could say the intrinsic implementation has to do the right thing because it's decided when you encode it, right? It's not a runtime overhead thing, but I don't know. I think it's easier to reason about this thing if you treat this as x86 float comparison mode, and then you do whatever x86 does.
So another question: should it be nested in the type? So the type is a bunch of static methods. You can now in C# do using on a static method and then just call convert vector, compare vector. And then if the enum was nested inside the static type, you could just say float comparison mode that blah.
I think this gets used in AVX, but also in maybe AVX2 and SSC maybe. So.
Maybe that's okay, but that basically means that you can import the static class. You can now call methods as if they were globals, except if you pass this enum, now you have to specify the type name that maybe you don't remember anymore. But maybe that's fine.
Having gotten to this point, like getting to the actual method and trying to do this, just doesn't sound like that would be too hard. People to have to remember the type that it came from.
With IDE completion.
Yeah.
That's right.
Let me just quickly scroll through how much more we have. Okay, we have only this one section left. Seems like we can finish that.
And that was this is more of like an example.
Yeah, this is more of an example. Yeah.
And that's good.
Oh, nice. Hope we should have started with this. made the move maybe a bit easier.
This example, we show that with this intrinsic, programmers can really control the low-level instruction, and for current the vector T, it's hard to do this shuffle stuff. And other example shows we can do the more efficient SIMD conditional branches with our blend V or other instructions.
Was it intentional not to have the is supported check in this example?
I'm sorry.
The is supported check.
Right. So it's in the main. So that's the function, and then this is the main.
Oh, okay. I see.
So let me get this straight. So because I'm not very much a Cindy guy, probably should be more than I'm not. Given that I PM the other feature, but basically the idea here is that you take basically a large array of floats and you basically reorder them into this structure here, right? Is that basically what this does? I'm trying to like understand what this method does conceptually. It just basically rearranges those vectors into basically that structure here, right?
Yeah, because usually the data is stored in the memory within AOS structure. Yeah, we need to convert it to SOA structure, and to do the same-day programming. Yeah, and then we can get a higher throughput.
Right. And that was precisely the thing that we couldn't give people a good solution to, because it requires essentially the shuffle operations, which we don't have right now because we're size independent. Right. Yeah, but that's kind of cool. And then I guess, yeah, the idea is that you have basically different versions of that method and that struct depending on how much of different specs you want to support, right? Yeah. It's a cool sample.
Yeah, see on that second one, I'd go on just bring up the naming again with the compare to vector 256. If that was like compare and blend variables, blend, and convert perhaps with a generic.
Yeah, we'll go back and double check and reply on that. Yeah, I think there's a good reason why we did it that way.
But I have to say, it reads pretty well, considering how bad it is. Like, I mean, yeah, this is wrong, right? But I don't know if we can do anything better with that. But I can see people writing that code and don't feel like they have to, tease their brain out. Modular the normal mind bending that you have to do when you do sim.
And you can in C# you can make it somewhat simpler by using static on AVX and float comparison mode, and then you can get rid of the class and enum prefix there if you wanted to.
Right. You can actually setting using an enum. I didn't know that. Class is new. That makes sense, I guess. Yeah, pretty cool.
And this is an example with the scalar intrinsic. And we also provide a CRC32 or pop count, 18-0 count this scalar intrinsic.
Yeah. I think the only feedback that came up last time is that we said basically that we generally do not want to provide software fallbacks for all the stuff we offer. But then maybe some pieces where software fallback makes sense. For example, CRC is a fairly common thing you probably should have software fallback for. But we also said it probably shouldn't live on the types. It probably should be a completely disjoint VCL type somewhere else. It just happened to be a good replacement for that intrinsic here. Otherwise, like, we sign up for too much work in the intrinsic space.
So what we are saying here is software fallback should be on the developer.
Yeah.
If they want to provide it.
No, I understand that. I mean, I'm saying, like, somebody brought this up because I think the last sample code we looked at basically said in the else just long error-prone code or something in the comment. And then somebody said, well, it really seems like the VCL should have a software fallback for CRC. Yeah. And then I said, well, that makes sense, but I just don't think we should have that literally in the SSE for you, because somebody said we could just have a software fallback. They said, don't do that because then it completely muddies the water on, like, when do you have a software fallback, when you don't have a software fallback. It's completely disjoint type, and the only commonality is that they're both called CRC, right? And that's where that ends.
Yeah, and it wouldn't be in the x86 namespace.
Yeah, it would be like, I don't know.
And they'd follow somebody would have to provide it and it'd go through the normal core effects API review as a separate thing.
Right. The only question is whether we could write our implementation doing that already, so we don't have to. So basically, the method would always be fast, essentially. You could do that. All right. So I think a ton of nodes. What I will do is I will just publish the nodes out. It probably takes me an hour or so to actually type them up so that I can also understand them in a week from now. And then the video goes online. Are there any more questions? What is the next step on your side? You already have like an implementation. You're going to basically get more runway with like trials, downloads. Like how does that work?
So we would like to enable a subset of these intrinsics, right? To see how it goes.
Right.
And I think obviously this is a large number of method or functions that are involved. So if you can, so the idea is we would work with your help to enable some of these intrinsic functions, and then basically open it up for people to look and contribute.
Yeah.
I think, and I mentioned as much on the issue, if we can get a few instructions done and have a little bit of documentation instructing users how to sign up for a set of intrinsics to port, and then a set of steps for them to add those intrinsics, because it should be a fairly mechanical process after the first couple, then there's multiple members of the community that would be willing to come in and help get this done.
Especially if you could figure out some way to have some Intel-specific badge that you earned by adding it.
Sign me up.
Somebody would. Yeah, I was hoping for you to say that, Ben.
We will update the proposal based on today's meeting and the discussion from the technical issue. Once this proposal gets approved, we will upload our C# API to code review. Maybe more questions.
And then we're going to have to do some infrastructure bits. Right? No. That was the royal we.
Did we address whether is supported should be a property or method?
You're all saying that it should be a property?
Yeah, that's this.
So the only kind of comment about this, if we ever want to add like ability to query for more, it would be better if it was a method. Because then we can add an overload that takes some parameter and says what's exactly supported. Yeah. The moment we make it a property, that's not an option anymore.
Well, you could still add a method that takes an argument. It's just not.
Like, it would be now very weird.
I'm wondering whether that kind of query should actually be distributed among all the types, or whether you're looking at some kind of sort of processor specific, like, please, here's the intrinsic to like, this is what the processor will say about all its capabilities.
Well, but we were talking about like today, there will be cases where somebody will have to say return false from is supported, despite the fact that maybe they support, they could support 2 out of 10 methods in this type. So for now,
what was that thing in there was a link up with the C# compiler with, I don't know whether it was strings or something like that, where you could flag what the runtime supported to the C# compiler. I'm wondering if that's related in some way.
It might be.
Well, I would
as an approach.
I think the problem is so I can only picture a world where they either have an all or nothing check, or it's super granular. I don't think there's anything sensible in between.
Sure.
Okay. And I think if we go all the way to every single method is up for querying, then I think the design is kind of a failure because it's impossible to reason about that. So I would almost put the stake in the ground and say, like, if we ever have to do something, I'd rather we expose some CPU ID capability, and then just say the customer has to work this particular CPU around.
This is what I was just saying.
Everything else we have, like, I mean, same with the runtime, right? If you know that, oh, you know, UWP, I don't know, .NET Native 4.5 fucked over these two methods, well, then check for this particular thing and don't call those two methods. And then you just...
So if we feel that we don't need it, then yes, it should be available.
All right.
I mean, the example of a non-implementation in the runtime is widen and narrow at the moment, but that's because the API advanced faster than the runtime. So there's no, you can check vectors are hardware accelerated, but that doesn't mean widen and narrow are. If you see what I mean. So it'd be good not to get in that situation again.
Yeah, and I think if we end up finding any instructions that fall into the category of a runtime is almost always going to implement it, but they might not implement others, I could see maybe CRC32 and SSE42 falling under that. Then exposing an individual property could be discussed for that particular method at that time, but I don't think that's going to be the majority case.
Yeah, that's a good point. If it's an exception to the rule, then we don't need it supported with a parameter. We just said the method is something specific supported.
Yeah. All right, then I think we have it all. Thank you guys online.
Thank you.